What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today, I haven't really done a live stream in a long time, so I guess I'll just do a live stream today. I mean, I haven't done this in a while, and I haven't really uploaded that consistently. Well, I did 2 days ago. Yeah, I did. But yeah, I also haven't been doing AtCoder at all. So, you know what? We are going to do a live stream right now, and we are just going to do a virtual contest that's going to begin in 5 minutes of AtCoder regular 1111. I feel like I'm getting a little better at solving ad hoc problems because, when you solve ad hoc problems on AtCoder, it starts translating over on code forces. So I feel like I am getting better at those. So my goal is to be able to solve problems A and B for every contest. And yeah, so then that'll get me to green, or A, B, and C. So yeah, for AtCoder is a little more difficult, and my battery's running low. But AtCoder is a little bit more difficult, so I'm thinking about, in order to improve, I'm gonna try to solve just one problem on AtCoder, and that's pretty good already because AtCoder regular contests are more difficult than the beginner one. So yeah, that's the thing. So yeah, let's just see if what we could do here. And where is my mouse? Okay, so we are going to do this in 3 minutes. We'll do that. Let's see. And we're gonna do this. Yeah, I know I have not been live streaming at all in a while, so this is kind of strange. I think like no one's probably watching at all, but it's okay. It is what it is, what it is. It's all right. But being able to live stream, live streaming is fun though. Not gonna lie, it is fun. Yeah. So let's actually just do a contest. I feel like maybe I should have like a schedule of live streaming. Every time I live stream, just just live stream, and then maybe I should make them private or unlisted. I don't know. And then like cut parts of the live stream, because that's what some people do. Yeah, but I don't know. No clue. No clue yet. Let's see. So in 2 minutes we'll start coding, and then just see how it goes. Basically, my goal is this New Year's is try to get to green, and then try to get to green on code forces, and then for AtCoder try to get to brown. I think that's what it is. I don't know. But yeah, I always never get to go on AtCoder because it's like 6 a.m. to wake up, and I just fall asleep the whole time when I'm on AtCoder. But I don't know. Let me know in the comment section below what you guys think. What time is it in India right now, actually? Oh, whoops. I clicked that instead of... Oh, wait. Yeah, contest begin in 2 minutes. Okay. So yeah, I'll look at the problem soon, and then we'll just start solving. This was what I did yesterday for one of another problems. I realize some people have like macros what they just submit. I might actually do that. So from now on, I'm just gonna have like, for DFS and BFS, I might have like a code above it that says BFS or DFS to do. So then I don't have to type it out over and over again. So every time I submit something, I do that. For now on, I also have surround, which is just all the coordinates from left, right, top, bottom, diagonals. So these are good. I do this so then I don't have to, deal with those parts. Like retype like different coordinates. So yeah, that's like if we have like a problem about chess or something. Which problem is this? This is not a problem. I'm not actually doing any problem right now. I'm actually not doing any problem right now. I'm actually, what I'm doing, if you just joined the live stream, is I'm about to start the virtual contest of 1111. So yeah. Yeah, it's no problem right now. I'll actually make this pop up so then you don't have to keep reading back and forth. So yeah. Yeah. So yeah, I feel like You know, honestly, I feel like people who are good at math competitions end up actually becoming expert immediately. Like they shoot very high in code forces or AtCoder in competitive programming because I feel like if you're good at math competitions, end up getting good at these type of problems. Like solving ad hoc problems are just observation. I feel like people who are good at math competitions end up doing well in these. I don't know. I never did math competitions when I was younger, so. But yeah, that's generally the gist of it. All right, let's start. Okay, remaining 2 hours. Simple math 2. What is? Oh shit. Okay. Find the remainder when 10 to the n is divided by 10 to the n over m is divided by m. Floor. Okay. 10 to the n divided by m. Floor is divided by m. Okay, so I'm gonna actually draw this out. Here's how I'm gonna start with it. Okay, so anytime we see a floor, I think about divisibility, right? So divisibility. Anytime I see a floor, I think about divisibility. So let me actually go through Google Sketch. Okay, so they say 10 to the n. N could be 10 to the 18. So first of all, when we floor something, right, that means we round downwards. Okay, so when I see 10 to the n over m, so 10 to the n over m, floor. Okay, let's think. Okay, so let's say this is not divisible by m, right? So 10 to the n is not divisible by m, right? That means, okay, well, actually, let's start with it is divisible by it. Okay, so let's say 10 to the n is divisible by m. Okay, so I don't know, let m equals to 2, right? And then n is equal to 1, okay? So then that's going to give us 10 to the first power 10 over 2, which is going to give us 5, right? Now what they want is, what is the remainder when you divide by it, I think? Find the remainder when you divide it by m. So if we take this and we divide it by m, which is 2, the remainder, which is actually mod 5 mod by 2 is going to give you 2, right? I think so. No, it's going to give you 1. Okay, whoops. So this is going to give you 1. Okay, so is it just n? Is it just n when n is divisible by m? 10 to the n is divisible by m. Okay, so what numbers are divisible by 10 to the n? So those are probably numbers that are divisible by 10, which is probably going to be 2 and 5. 2 and 5, right? Right? 2, 5, 1, or 10. Right? Maybe it's also divisible by 4. Depending, right? Because 100 is divisible by 4. 3, yeah. So maybe 4. Maybe 4. Maybe 4. Okay, let's think. Over m. Let's say 10 to the n is not divisible by m. So now let's say, okay, I'm trying to think of many situations this could be possible. I'm going to clear this. So 10 to the n. So we wanted to find this mod by m, right? Let's say this is not divisible by it. So let's say n is equal to 2, so 100, right? M is equal to 3. Okay, so let's see what this gives us. This is going to give us 100 over 3. Floor mod by 3. So this is going to give us 3, 3, 9, 10, 3, 9. 9, 1. So floor of that is going to be through 33. Mod by 3 is going to give you 0. So if it's not divisible by it, you just make it 0. Let's try other ones. Okay, let's do this. 10 to the n m. I keep having to write this over and over again. Maybe I'll just like minimize it next time. Let's try 2 again, and then this will be 100, and then let's m is equal to 6, right? So let's get 100 over 6. What does that give us? Guys, what does that give us? So that gives us 1, 6, 40, 4, 5, 6, 6, 36, 4. So this is going to give us 16, right? So this is going to give us 16, right? Yeah, so 16 mod by 6. No, it doesn't give you 0, so this is going to be mod by 6. 1, 6, that is 2, 3, 2, 12, 4. Oh, you get 4. That's the same thing as this. Huh. Ten to the 16. So is it just going to be 10 to the n mod by m? Is that what it is? Let's try something else. Let's try 7. Whoops. Try 7. Let's see. 100 over 7 mod by 7. Whoa. What does this give us? I might actually just take a calculator, because I don't have to keep doing this over and over again. 14. It's about 14. This is 14 mod by 7. We're just going to give you 0. What's the remainder when 100 mod by 3, 2, 1, 7, 3, 4 is 28? No, the remainder is 2. Huh. So if it's not divisible by it, is it just 0? But we saw with 6 that that's not the case. Right? With 6 we had some other thing. For now on, I'm going to do this, okay? Oh, what the? Let's see. Okay, I don't know. Let's try 8. Okay, so n is equal to 2, m is equal to 8. So we have 100 over 8 mod by 8. So that gives us 100 over 8 mod by 8. Gives us about 12. 12 mod by 8. That's going to give you 2184. It's going to give you 4. But what is 100 mod by 8? 1, 8, 20, 3, 2, 16, 4. So that's the same thing. Maybe it is just 10 to the n mod by m. But if that's the case, how come that other time when we had 6, that wasn't right? Let's calculate 6 again. Sorry guys, I've had to calculate again. Six 36 4. 16 mod by 6. What is that going to give us? Oh, it gives us 4. You know what? I'm just going to say it, all right? I'm just going to do 10 to the n mod by m. Okay? I'm just going to do that. All right. So that means we just have to do binomial exponentiation, I think. So let's try that. Whoa, I think you could binary search a max value. You could try increasing as you take the stuff. Maybe I'll try that later. I'm just gonna use binomial binary exponentiation. That's what I'm gonna do. Okay, so CNNM. Okay, and then what I'm going to do is I'm going to just do while m is greater than or equal to 0. While n is greater than or equal to 0. And what I'm going to do is I'm going to do take answer is 1, take answer times 10, then mod by m. Okay. Should work. If this doesn't, I'm gonna try the other way, which was making it into an exponent. Let's see. 1, 2, let's see what does 1, 2 give us. That didn't do anything. Oh, test cases. There's only one test case. See days. Oh, whoops. I thought it was in Python for a second. Okay, let's see. Quickly. What is the problem? What's the problem? Oh. Okay. Zero. Okay, that's not right. Let's see. What is the actual answer? 1, 2 is 1. Okay, what we're going to say is if it's not divisible by it. So if it's not divisible by it, we do this, okay? Okay, 10 to the n. Okay. What values are not divisible by 10? So if it's not 2, 5, yeah, if it's not 2 or 5. So if m is not equal to 2, then we do this. So let's actually try values that are not 2 and 5. What the hell? Let's see where it gives us. So that's 2, 7 should give us 0. That gives us 2 fudge cakes. What are we doing wrong? What is X bar down? What did we say it was? We said it was 10 to the center. You're saying to use binary search. I don't know if... I mean, we could do that, but I just don't... I'll try. Okay, I'll try using binary search later. If that doesn't work, then I'll try binary search. But yeah, I don't... That means you have to try 10 to the 18th values, right? Right. That would be O of M. So, try values up to M. Up to 10,000? Find the remainder when... So that would mean... I mean, we could try that. All right, let me try one more thing, okay? Let me try one more thing. Let's see if... All right, let's try it. All right, I'll try binary search. We'll see if that works or not. Okay, smallest value is 1, high is 1,000, I think, right? So low is equal to 1. High is equal to, what was it? 10,000? 10,000, yeah. Okay. While low is less than high, we'll take the middle. And then after that, we need to check if it's right or not. If mid is equal to, oh Lord mercy, how are you gonna binary search this? N could be super huge though. You're gonna get an overflow here. I mean, you can't even check it with the value. Right? Because basically you would have to do this times by M plus that value is going to equal to 10 to the n. Right? Because like, okay, so we have 10 to the n over m and then mod this by m, right? Let's say this is equal to like, I don't know, w, right? If you want to check if w is right, you would have to do w times 10 to the n over m plus m is equal to 10 to the n, I think. You have to check this, right? So you have to take this w, multiply it by 10 to the n over m. I think that's what you have to do. Or, wait a minute. Wait, if I do 5 over 2, 2 do 1, 2 do 1, mod by 2, is it 1? 1 times 2, Wait, so let's see. Say I have 5 over mod by 2, then I have to do is equal to 1, right? So I have to do 1 times 2. Check if this is right. I have to do 1 times 2 plus something plus 2 is must equal to 5. Yeah, so I have to do 1 times m. Oh, I have to do 1 times m. So I have to do w times m. I have to do w times m plus m is equal to 10 over n. 10 to the n. 10 to the n over m. That's what I have to do. Regardless, you have to calculate this number. You raise everything to the power. If you raise anything to the power, what does that do? Remember we had wait a minute, hold up. 10 to the n. Okay, so basically what I have to do is I have to take w times by m plus m times by m plus m must equal to this. W times by m plus m must equal to, yeah, so 5 plus. That's mid. Check is going to equal to mid times by, so our answer is mid times by m plus m. Check if check is equal to 10 to the power divided by m, which is this. We have to check this. But the problem is that we don't know if this is going to overflow. So we have to find a way to simplify this. 10 to the n over m. Maybe I could get rid of this power. So what if I do 10 to the m of 1 over n? And then put this to the power of n. Right? That will work. Right? Take 10 divided by m. Or how would but what I need is I need to figure out how to calculate modulus. This is divisible by 2, then we're gonna get 2 mod by 2 is equal to 0. Wait, hold up, guys. If this is divisible by, if 10 to the n is divisible by m, then w would be 0. Right? If this is divisible by this, this should become 0. Huh. I don't know. Have you solved number of islands problem? I finally solved it. If so, to use DFS or BFS for it. What was number of islands? Is that this challenge? Oh no, that's not this. Number of islands. Azure, well, what is number of islands? Number of islands. What problem is that? Oh, this is leak code. Oh, you want me to do this? Oh, this is medium. Yeah, I'm not gonna do that problem right now. Right now, let's try to solve this hard problem. Let's try to think. The more we think, the better our brain weaves. So I could rewrite it to become this. Then I could check if this is divisible by this. Raise it to the n power. I don't know. This is difficult. Difficult. Very difficult. Okay. I mean, we could. Okay, we could actually. Okay, we could do binary search this way. Let's assuming that it doesn't overflow. So if this check is greater than 10 to the n power, we're gonna set middle is equal to I don't know. High is equal to mid minus 1. Right? If our check else if check is less than low is equal to mid plus 1, else we print out mid and then we break. Print out mid and then we break. Okay, let's see. 2, 7 should give us 0. Okay, that gives us nothing. Something happened. Okay, hold up. Oh, we have to start with 0. Yeah. 2, 7 still gives us nothing. Hold up. What is the problem? I think the power is the problem. Yeah, the power gives us this. See out. Actually, break will print out a low. Break, print out low. I don't know. Let's see. 2, 7. What the hell just happened? 2, 7 gives us 2. What the hell? Okay. Why does it give low? Hold up. If they're equal, put 0? I don't know. Let's keep trying. How much time do we have left? How much time do we have left? An hour and 30. Ten to the n over m divided by m. Okay, if m is equal to 2 or 5, answer 0. I think. No. Fuck. If two. And wait. M is equal to 2. No, your answer is 1. If it's 2, the answer would be 1. If it's 5, the answer would be 0. I think. Right? If the answer is 5, it would be 0. So, like, hold up. I could be wrong, but let's try. Okay, so let's say we have 10 to the... What the hell just happened there? So let's say we have 10 to the second over 5. So n is equal to 2, m is equal to 5. Lower bound is going to give us 100 over 2, 5, which is 20. Which is going to be 20 mod by 5, is going to give you 0, because that was divisible. So, yeah, let's try, I mean, we could keep going. Let's try 4. This is going to go over 5. This is going to give you 10 to the 4th, which is going to give you 10,000 over 5, which is going to give you 2,000 mod by 5 0. Okay, so if it's equal to 2, we print out 1. If m is equal to 5, we print out 0. Okay, so maybe you shouldn't try binary search. Maybe this works. I don't know. Okay, so maybe there's just a bug here. I don't know. For now, let's just do if m is equal to 2. See out 0. What if it was 10? Oh boy, if it was 10, you would get 0 also, right? 10 second. This is going to give you 10 mod by 10, which is going to give you 0. So if it's 10, it should give you 0. So okay. Else, what are the different possible values of m? 10,000. Try 1. Well, anything divisible by 1, mod by 1, anything mod by 1 is 0, right? I'm not 100% sure about that. Yeah, anything mod by 1 is 0. So if it's 1, we just print 0. Yeah, so if this is 1. Okay, 2, 0, 1, 2, let's try 4. Is 4 the same thing as 2? So this is 100 over 4, which gives you 25. You get 1. Okay, let's see. Let's try this. 1,000 over 4 is 250. 250 mod by 4. What does that give us? 250 mod by 4. Let's see, 250 mod by 4. Gives you 2. Wait a minute. 10,000 I'm getting an epiphany. Hold up. 2 to the second. 2 to the... You could rewrite this as 2 times 5 to the third divided by 2 to the second, which is going to give you 2 to the third times 5 to the third over 2 to the second, which gives you 2 times 5 to the third. Does that help you though? What the hell? I don't know where I was going with that. Four. So 4 gives us 2. This 4 gave us 2. 250 divided by 2. Okay. Let's see. Hold up. What? Okay, that's really weird. Okay. Try 5. Let's try 5. 4 gives us... Okay, so if n is equal to 2, I'm trying to think. Four is okay. So 4 is... It's so weird. Okay, so if I let n is equal to 2 and m is equal to 4, I get 1. If n equals to 3, m is equal to 4, I get 2. But anything 4 or higher, I get 0. So is it 4 mod by 2? If n is greater than m, so okay, so if n is greater than m, is it just 0? Let's try different numbers actually. Let's try 5. If n is greater than m. I think it is 0. What? It's too weird. I don't think that's right, though. No, that's not right. N is greater than M. Yeah, that's definitely not right. Wait, let's take this mod by that. No. I don't know. I don't know, actually. I'm not 100% sure. I feel like... I don't know. Okay, let's see. If it's divisible by it, then yeah. Then it's a 0. It's 10, 0, 1, 0. What about 2? 13. What if n is 13? About 2-ish. We have to do floor. Round. Seven, 6, 9. 7, 6, 9 mod by 13. 7, 6, 9 mod by 13 gives us, what does this give us? 2. 2. 13 gives us 2. Same thing as 3. Does 3 give you 2? Does 3 give us 2? See, 10 to the 5th, 10 to the 9. 10 to the 3rd, 10 to the 4th, mod by... Three gives you 0. So 13 and 3 are different. Oh boy. I don't know. I don't know, man. Okay, I'll try one more thing. Oh boy. I don't know what I'm doing. I have no clue what I'm doing. This is really difficult. Fuck this. This is fucking difficult. Fuck this. Why is it so difficult? Okay, what I'm gonna do, we have M. We split this into 2 times 5 to the n. And then M, we're gonna split this to okay, if it's divisible by 2 or 5, right? If M is divisible by 2, you get 1. Wait, 2 or 5, 10. 15. Is 15 right? Let's see. Divide by 15. Mod by 15. Mod by 15. You get 6. Nope. Oh boy. Divided by 10. This is divided by 5. If this is 15, if n is 15 is 3 times 5, then you could 1 over n this. Take this exponent, put it down, put this to the total exponent of n. M to the 1 over n. 10 divided by m to the 1 over n. Then power of n. 10 divided by n over m power of n. I have no idea. Brute force. Alright, we're brute forcing. If w times by m plus m is equal to power 10 to the n over n, that's not I, let's make it I. See how I return. Hopefully this works, but I could be completely wrong. Come on. 3 wrong answers. 3 right answers, most of them wrong. Okay, let's keep trying. 1, 2 should give me 1. Two gives you 1. Okay, that's right. Let's see, 2, 7 should give you 0. 2, 7 gives you nothing. Why? Two 7 gives you 0. Should give you 0. Oh, we should try 0. Still nothing. Okay, so something is wrong. Something is wrong. 2, 7. 0 plus 0, 10 to the n over m. I times m plus m should equal to 10 to the power of n over m floor. Ten to the power of n. 10 to the power of n is 100 over 7 divided by 7. 100 over 7 mod by 7. Should give you 0. Ah, shit. Wait a minute. Okay. So suppose this is 5 mod by 2. I think it's 1. 1 times 2 plus 2 should equal to 5. This should be 14 mod by 7 equals to 0. 0 times 7 plus 7 should give you 14. No, but that's because we rounded down. Okay, you know what? Let's just try. Okay. C out power 10 to this mod by M. It's a crusty crab. It's a crusty crab. Let's see if this works. 4 wrong. We got a few. We need to figure out why the N power is not working. That's the big problem. Why doesn't this work for the... Because we're getting overflow, right? We're getting overflow because of this. Like, if I did, like, I don't know, 10,000. Let's see. What if we had, like, on, like, a bunch of thousands? I have no idea. This is difficult. This is really difficult. Super duper difficult. Maybe it has to do with the beginning here. Hold up. I don't know. Let's see. Let's try something. 0. Two, it should give you 0. This is only if let's see if we could pass more cases here. Come on. Give me something. Give me fucking something. Think we got a little more? Do we? Do we get a little more? 1, 2, 3, 4, 5, 6, 7, 8, 9. Special case. Example 2 was wrong. We could definitely try to figure out example 2. Try to figure out example 2. What was example 2? 2, 7 should give you... 1, 2. Try this. Negative. Oh, that's wrong. Okay, that's definitely wrong. Okay. 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 How do we do this? It's so hard. Why is it so hard? I am using long long. I'm using long long. They're all long longs. In fact, hell, like you could use, because you're raising the power to the, you're raising the power to 10 to the 10th. So that's why 10 to the 100th. I don't know. You have to keep trying. Let's see. Let's see. Let's see. Try again. Okay, that's still wrong. Okay, example 2. So the problem is we have some example 2, max random, small 0, 1, 0, 2, small 5, 6, 7, 8, 9. Would I get all the small ones right if I just got rid of the beginning values? So I got rid of this. Right? Let's see if we get all the small values right. No, I don't. Did I get even smaller? No, I don't. Okay. Let's keep thinking. I feel like the more we think, the more our brains get larger. You know what I mean, guys? Do you get what I mean? Okay. Okay. What I'm going to do is I'm going to take the 10. Take M, and I'm going to do it to the 1 over N power. So I'm going to do 10 over N. So I'm taking this, and I'm going to make this into it's going to make it equal to 10 to the N over M to the 1 over N, right? Then I'm going to take this N, and I'm going to put it on the outside. Okay? Right? And then using this, I will mod it by M. This value, I will mod it by M. And I'll use binomial, the exponentiation with this. Okay, so yeah, I'll try that. So I'll take 10. So this is going to be like base is going to equal to 10 1 over N power. Power of this 1 over N. Yeah, okay. And then what I'm going to do is I'm going to do while N is greater than 0, N minus minus, M N minus minus. Then we take this, we're gonna do base is equal to base times by base mod by M. Let's see. Let's see if this works. Oh no, damn. Dang it. Lagging. Why isn't it working? What does base equal? Base is equal to 10. Oh, I said n. Fudge. Oh, god damn. N is too big. N is too big. Oh boy. Oh boy. Oh boy. Okay, this is very difficult. I'm not gonna lie. This problem is very difficult. You can't just do that. Dun 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 dun. Why did I go on my Gmail? Okay. Okay. Gotta think. Gotta keep thinking. Thinking. Let's look at the standings. I bet you there's some. Ah, damn! This person solved it in 3 minutes. That's insane. All right, this person solved it in an hour, 9 minutes. Okay, that I don't know. Maybe he just got in late. Actually, that might just would have been happened. He probably got in late. But yeah, this is difficult. 3 minutes, programmatic. I can't look at. I don't want to look at his code yet. Okay, let's break this down. Let's break it down again. Let's break it down. Let's keep trying. Okay, 10 to the second over. Let's try 7. Let's take 10, and we're gonna make it into 2 times 5 to the second. 7.
Everything good, Michael?
Yep. Hmm. Let's see. Try with. Oh boy. Oh boy. Okay. Okay. 10 divided by 7. So 4 times 5, 25,000. 4, 7, 25 over 7. 25 over 7 is 321, 4. 4 over 7 is 4. This is difficult. Okay. I'm trying to figure out a pattern. This is so difficult. I'm running out of ideas. Floor of 10 powers over m, I mean. Floor of 10 powers over m. I mean, if it's divisible by m, then of course, then the answer is 0. If m is divisible by 10, the answer is 0. Mod it by 10? No. The floor of 10 powers divided by m. Think about the pattern. If the floor of 10 powers is divided by m. Okay, let's see. So if m is greater than, it's just 0. N is greater than, no, that's not true. That's just not true. Like if it's 3, 4, 4. Is there 0? Wait a minute. No, that's not right. This. Ugh. Okay, let's keep thinking. Yeah, it's not just 0. Just do it. Just do it. You could divide 10 to the k over m for some n k less than n. Huh? What? You can divide 10 to the k over m for some k less than n. For some k less than n. I can divide 10 to the k over m for some k less than n. Then take 10 to the n minus k, multiply by the rest, and then decimals. And 10 to the k greater than m. Just do it. 10 to the k n minus 4. This is hurting my brain. What do you mean by that? Take the k n value. It's already an hour and 16 minutes. $49 more minutes to go. You know what? I think I've given up. Let's just look at the editorial. All right, let's just look at the editorial. I tried a lot. I tried everything already. All right, I'm going to look at the editorial. Evinima. Let's see. You can compute the formula with the Python below and have TLE. Yeah, that's what I was doing. This is because the 10 to the power n is 2 other, yes. Here at AtCoder, we often consider very large numbers mod 9984453. We can assume some mod this time as well instead of handling 10 to the n itself. Turns out 10, we can use 10 to the n mod by m squared instead of 10 to the n. We can show that subtracting multiples of m squared from 10 to the n does not affect the answer. So if you take a k minus m squared, you get does not affect the answer. We could subtract multiples of m squared from 10 to the n. Oh, so like multiples of m squared. So you're saying like minus k m squared over m is equal to 10 to the n over m minus 10 to the n over m minus km. Which is equal to 10 to the n over m mod by m. Km. What? I don't understand. What difference does it? You still have to calculate 10 to the n though, right? N mod by m? Is that what they mean? I don't know. Let's look at the... Oh, I use Python. I need a C++ user. Let's see. If it's odd, we multiply by 10 mod by m times m. Even, then we just mod by m squared. I think this is fast exponentiation. Not sure what it's doing though. This is times by 2. Wait, okay. Hold up. Yeah, this is what it's doing. Hold up. So I'll type this up, but this is to calculate 10 to the n. I'll type it up actually. Let's see. X is equal to x mod by p. Is that what they did here? Answer is equal to answer times by x mod by m times m. X is equal to 10. Okay, let's do that. But okay, but ants is equal to 1. Okay. What did they do? While n is greater than 0, shift 1 by 1, so that multiplies it by 2. Ants is equal to res is equal to res times by res. Mod by m. Mod by m times m. Ants is equal to what? Okay, whatever. Okay, I'll maybe I should go over this. This is gonna be another video topic probably. I'm just gonna copy this. Actually, I'll type it out. N shift to right, x equals x times x mod by p. X is base. Mod by m times m. So are we doing m times m now? Y is n. Do we even need to divide it by m? Yeah, I think you still have to divide by m. But oh wow. Ants is equal to 1. Yeah, okay, that's really weird. Okay, why? Pragma. Whoops. Not Lilo and Stitch guy. NP power 10 mod by P. NP. P is n times m. Mod by PM. Huh. Mod by M by M. 10 to the n mod by M by M. Yeah, I don't know. I think it has to do with fast exponentiation. But then okay, but why do we divide by M in the end though? Does this guy divide by M? No, he mods by M. Fast exponentiation. Doing that to P, which is M times M, and then he divides it by M. Then he mods it by M. This might actually make more sense. I don't know. Modulo M, as I said. So mod 10 to the 8th floor. 10 to the 10 square modulo M squared over M modulo by M. Okay. Yeah, I think I sort of get it, but I don't know. I just don't know why it works, you know? Because I like if you changing subtracting by M squared doesn't affect anything. Like that doesn't. It turns out we could use 10 squared mod M squared instead of 10 to the n. We show that subtracting by M squared does not affect the answer. Okay, sure. All right. Well, that's it for today, guys. I hope you guys enjoyed this video. It was a long live stream. Rate, comment, subscribe. I'll check you guys later. I'm really tired now. But yeah, apparently just use fast exponentiation and use m squared instead of m. So I'll go over modulo exponentiation in another video. But yeah, rate, comment, subscribe. I'll check you guys.